And we're live. Hello, everybody. Let us know how things are. I need to minimize myself on this window. And then you can see Thor perfectly fine. Sweet.
Hooray!
Woohoo! Starting. No, starting is actually duplicate this, remove this. Are you sure you want to? Yes. And then I guess
Well, thanks
anyone there
for
yet?
those that are here that were waiting, or those watching the recording later. Welcome to yet another episode of Let's Profile.
Let's not mention to the people watching the recording that we started 15 minutes late. Also,
Yes, if you're watching the recording, this started on time and there were no technical difficulties.
I'm happy you call it technical difficulties and not me being late and haven't
That is
prepared
technically
the
a difficulty, so
setup.
technically correct. Hello, Sumira. Welcome back. So today on Let's Profile, episode 5, we are going to start by looking at, oh my goodness, stop playing with the sizes. We're going to start by looking at the Prometheus Node Exporter and seeing what it looks like in terms of CPU usage and if there's anything we can do to improve it.
Yep. And before that, because both of us have like kind of a lot of real estate on the screen, I might just cut ourselves a bit shorter. How about that? So I don't take away too much screen estate.
Sounds good.
And this one, no, this one, please. Yes. And I was wondering if before we even dive into anything, whether or not we should maybe even take a look at the amazing blog post that Kemal has written and just like talk a bit about flame graphs, because that was released this week.
Sure.
Just go through that one a bit and see if people have questions or whatever. Right. Way less screen estate for the both of us and more screen estate for content. Oh my god, I'm now I'm over engineering the starting scene for no reason, but I think I have to just put the ice cube here. Oh, it doesn't work. It doesn't do emoji. What is wrong? What's
what
wrong
is that?
with
An
OBS?
orange slice?
Orange slice is a good one. No, I tried to, or not tried, but like in the text input, it actually has the ice cube. Because chilling, you know?
You put like some weird orange slices thing on there.
Yeah, I don't know what. Apparently it doesn't do Unicode.
All right.
I was expecting more from this software. Otherwise it's great, but doesn't seem like that's the case here. Cool. All right, so this is just also a backup screen for whenever we need to not show the screen for various reasons. So I'm happy to have that one. And then let's head over, and we just lost Thor. So let me copy Thor. Oh, there's a Thor.
Oh,
that's great. Good news. Let's move these over so we can get started.
We are extremely professional with our production.
I mean, we just did the whole thing live, the whole setup, you know?
Yeah, that's what I'm saying. We're very professional.
Yeah, it's like
that wasn't
tailored to our needs in this very moment. All right, I don't even have a browser on the screen yet. The hell?
Step 1.
Have a browser.
Install Firefox.
Yes. maybe hide the bookmarks. But yeah, I mean, we'll definitely dive into all the things Node Exporter, but I just had to, like, I was just like at lunch earlier and I was like contemplating, I think we should just like walk through this a bit and discuss this quite amazing blog post that Kemal has written this week, or the previous weeks actually, and then it was like published this week. So I guess, like, I don't know if anyone in chat gets the reference, or everybody in chat has read the blog post already.
I think everyone gets the reference. It's
Everyone,
not
totally
it's not a
obvious.
unique reference.
Ice and fire, flame graphs, and icicle graphs. Yeah. But yeah, I think it might make sense to at least like look at some of the things and how to read icicle graphs and flame graphs. So we skip a bunch of text, and you can go and read that later on. No disrespect, Kemal.
Yeah, we're not going to do story hour here.
Yeah. But yeah, I think overall this is just like, definitely go through and read all of this, but we can see the various dimensions of like icicle graphs and flame graphs, and this one is obviously the icicle graph, also because it has like cold colors, I guess. And then the other one is the flame graph, and the major difference is that now the stack is like bottom to top, whereas the icicle graph is like the other way around, I guess, right? So just like high level differences between those two things. But then it is quite amazing how it like walks through everything on how we have like a program that just calls a bunch of things. So actually, maybe a nitpick on the blog post. I don't know about you, Thor. Like, I usually put the func main to the very top of the package, so like it is right there, right?
Oh, see, I usually add comments to my functions, so that's my nitpick.
You are such a liar. No disrespect.
How dare you?
But yeah, like, yeah, comments would be great. I think it's like, can we agree that this is probably easy enough to understand on like how functions call each other?
Yes, I think it's fine. It's a wonderful blog post. Everyone should go and read it, especially if you're not terribly familiar with flame graphs or icicle graphs.
Exactly. But yeah, and then we're going through like all of this, where now you can see like the main function calling the function A, and then this one calling function B, and then calling function C, and C is just like in a for loop forever. So this kind of like the icicle graph is like top to bottom again. So we see it this way around, and then the flame graph's just going the other way around. And actually, let me put so we don't forget, let me actually put the link into the chat. So we have this here. People want to read on their own. And yeah, I think, yeah, let's add like 1,000 or 1,000,000 iterations in the of the for loop into the graph, and call it like concurrently, I guess, or 3 times. I guess it's not concurrent, right? Here.
Yeah.
And then adding, instead of like calling CCC 3 times after another, like have like D and E. So what does that look like? And as you can see now, we actually have like these 3 functions, all of them taking up like, I guess, counting to 1,000,000 takes like roughly 50 milliseconds. So we can see that like overall A calling B, and B like having the cumulative value of 150 milliseconds, because like C, D, and E, all of them had like roughly 50 milliseconds to run, or to like iterate to like 1,000,000. So that's kind of like the idea. And then again, like with the flame graph, we're going the other way around, right? So it's kind of, I don't know, is it a preference? I guess it's a preference, which one you like.
Yeah, it's just a visualization preference.
Yeah.
It's the same data either way.
I don't think we have like any plans on adding the flame graph to Parker. I guess that's like due to icicle graphs fitting our polar theme so well.
Yeah, I think that type of visualization add would be redundant.
Yeah, and I don't know, like I feel like once we have like we have like in Parker and Polar Signals Cloud, we have the we have like the metrics graph on top. So kind of like you nicely see like scrolling down, reading through, like looking through the page, you kind of like then see like the root right after the metrics graph, and then like everything that is less obvious, or like the root of the flame graph is just like right there. Whereas like otherwise you would need to like scroll all the way down, scroll past like all the like small stacks that might be making the flame graph super huge, and then eventually can read bottom up. So I think it like also makes sense to have just the icicle graph in the UI that we have. But yeah, it's just a visual preference, as you said. And then adding another function, and I guess like this one is now calling C instead of so we have like, we should have like another, like indirection here. As you can see, now we have these B and C, and then they each call like D, E, F. Colors, I think there was like a quote I remember. I don't know if it's in this version. Yeah, this one. I want to highlight the colors usually don't carry any specific meaning. And that's something like a bunch of people also while reviewing this blog post kind of stumbled upon. They were like, wait, what? Actually, they don't mean anything?
Yeah, it's just to visually separate items so it doesn't look like just a homogeneous colored blob.
Exactly, yeah. And I guess there are like different ways of how you can color them. So that's why we have like the color picker. So like everybody has a slightly different preference. Which one do you actually use, Thor?
I think I use rainbow just because it's the most fun.
Okay. Maybe like.
But do you want to go over how we color them and what the colors mean for?
Oh yeah, definitely. Yeah, maybe like before we do that, like in chat, maybe you can drop the you can drop like which like if you're using this and if you have changed the setting, you can drop which flame graph color profile you use. Yeah, I personally use the ocean one actually.
Yes, Kamal's here reviewing your work, Kamal.
Just because it was released this week, so I just couldn't resist not looking at this on stream. But yeah, it's an amazing resource, and I think it will have quite the long tail, and it should be equally relevant in like 3 years or whatever, right? Like flame graphs and icicle graphs won't change overnight, I guess. Let's hope for that. Otherwise, we need to redo the UI.
Well, maybe they become useless because there's a better way to visualize things in the future. That would be cool.
That would be also cool, yeah.
I don't know what that is, but you know, data visualization is not my strength, but that would be really cool.
Yep, I agree with that. I'm going to change your video slightly, Thor. I feel like we are like cutting parts of your head off, which is nice. Right. Updated that one.
No one's looking at my head anyways, it's fine.
Cool. So anyone want to like share what their color profile is? Again, like Thor uses rainbow, I use ocean actually. But yeah, what do the packet, or like what the colors mean? Maybe you want to like explain that. I don't know if we have, because this is like the closest we can.
Yeah, this is the closest. So yeah, the colors in Parka and Polar Signals Cloud are basically they're nice zooming. Are the package or application, or how would you describe what it is?
I think like
binary.
The binary, and what like Parker actually calls it is com. So it's like another name for executable. It's like, I don't even know what the like, maybe someone obviously in chat knows what.
But basically the colors allow us to delineate between different types of profiles that are currently displayed in the flame graph. So on this one, you can see like the kubelet is colored in this nice purple. And so you can quickly determine the kubelet is actually, if we just look at this profile, it's currently up on the screen, the kubelet is eating the majority of the resources.
Yeah, definitely. And then I think like a special one is like the runtime. So even though like on the very right it says kubelet here, I don't know if you can see my mouse on stream, but like this section still says kubelet, but we kind of differentiate everything that Go runtime does, for example, into a separate color. So you can see also right here, like a bunch of things the kubelet does is actually calling out to the runtime package, and then that usually allocates slices and does like allocations overall, etc. And some like garbage collection things. So those are also quite nice, like next to, I think, the other one obviously being the kernel stacks at the very left. You can nicely see the kernel. Oh, this is like, what is that? Like the read some directory.
Yeah.
And then most of the time is actually spent in reading the syscall here, or doing the syscall.
Yeah, you usually see the kernel being at the tail end of the icicles, because it's usually the last step that a program calls out to the kernel.
Yeah. Okay, so Frederick uses the rainbow color theme profile, and Kemal says he wants a monochrome palette for hardcore programmers. Yeah, if you want to make your life more difficult just to be cool, like, go for it. I think we can accept PRs with monochrome palettes. If you
We should
feel
create one that's just different shades of white.
Yeah.
You have like eggshell white, and I can't name another color of white, but
Agnostic white, right?
yeah, there we
PR
go.
white.
Just different shades of white.
Sumera is Team Ocean. Yes, Sumera. I think I'm with you there.
Okay.
Bonding over profile colors. Nice. Yeah, so I think that's a good summary of what the colors do. But I think there are like other ways of, like, every package gets a color or something. But I think, like, given that we have oftentimes lots of different packages within a single program already, I think the COM is a good way to keep things at least not too overloaded. And Frederick actually said in chat that, like, the COM is basically the mapping of the binary. So every other color profile reminds Sumera of gelato or candy.
I don't understand why that's a problem. If anything, you just gave reason to not be using Ocean.
Fair enough.
I want my cotton candy profile color
Cotton
scheme.
candy?
Yeah.
Ooh, I didn't see that update that you need to hover to play the animation.
Yeah, you got to keep your mouse over it.
Yeah, that's amazing. Okay, so we can even pause. Nice. So yeah, like how are the, like, how do we actually get to like icicle or flame graphs, right? Like, I think that is like the biggest thing. So the way the Parker agent, or even I guess the Go runtime does this, is just like over time looking at the stack. So like any given interval, the Parker agent does this like 19 times a second. It will like look at the current stack trace, or the kernel actually looks at the current stack trace, and then just collects that and appends that to a map that we can read from user space. So that's where we use eBPF for all of this. Is this like going to loop?
I don't think so. I think it ends the animation.
Okay. So like this is one profile, 19 hertz later, we see another one, and then a couple of milliseconds later, we see another one. So we collect them over time, and that's kind of what we do over and over, or like continuously, right?
Mm-hmm.
But yeah, this is how we get to like individual stack traces. If I go to this one, okay, I can just switch tabs to restart. Frederick says COM is the same for the whole process, whereas mapping can be different libraries that a stack might go through. Okay. So COM is kind of the executable in the end as well. Yeah. Yeah, and then to make more sense of all of it is we are actually taking the stack traces that we've seen, and then we are sorting them alphabetically. So you can already see, like, just by looking at these color schemes that we have in this like example, like this first shade of blue and then this like darker shade of blue, they get like grouped together just because they are sorted. So think of of it as like the names of the function there. So then we can nicely see, okay, all of these stack traces come from the same like second level stack function that we called in the stacks.
Mm-hmm.
And then the final and most interesting part is merging everything together. So yeah, I think this is kind of how we get to these end results. So really, like what you see is like the combination or a merged flame graph of all the like individual stack traces we've seen over time. It just happens to look like it was like a big chunk right here, which really is just more of a visualization to make it easier to read, other than like having the same function name 100 times right next to each other, and then you can't even read the function name because it can only see the first letter of the function name or something. And the same for flame graphs, just the other way around. Yeah, so calling the functions, calling each other. And yeah, I think this is a very, very important detail. You might want to describe this one, Thor, so I don't talk all the time.
I don't know which one we're looking at. The stream's a little behind on.
Should be coming up now.
We're talking about just this icicle graph here?
Yes, and the red lines beneath it.
I don't remember what the red lines were.
Okay, these are the leaves. So really what the red lines is like leaves. How much time, like looking at the leaves of a flame graph, or like the, I guess also leaves in the flame in the flame graph or the icicle graph. You can see that like we've spent so much time overall in the stack by looking at this function, the D here, or then the F. Like E didn't really itself spend too much time somewhere, because like the only time that only E was doing work was actually over here, where the other part of, or like the other duration of the function call was actually mostly spent in F. So E isn't even taking up that much CPU time, right? And I think that's like what the red lines try to communicate.
Worth mentioning, though, is it's not just time, right? This is just a display of flame or icicle graph is being taken up by the leaf nodes. It's also worth mentioning that this is obviously a sampling, and Parquet agent samples at 19 times a second. And then this is the accumulation of those samples, but it isn't strictly like your program spent this much time in function F or this much resources in function F. But with the samples, this is representative of the amount of resources that these functions are using. But it isn't, a perfect capturing of it, since it is sampling.
Yeah, all good points. Thank you for adding those. Yeah, I think this is like, just diving a bit deeper into that for the people that can't listen to us on the stream, basically, but just by reading through it. And then here's an actual flame graph in Parka, where you can now see, I guess this is actually a comparison, right? Yeah.
Yep, it's kubeproxy comparisons.
Yeah. All right, and then how do we find performance issues? And I guess that's what we're going to do next, is like actually look at just like looking at the width of these functions and seeing how much time they, or like resources, again, better to talk about resources here, right, Thor, than time. So this is kind of what we're looking at when looking at icicle graphs or flame graphs. Like we always like look for the biggest functions in terms of the resource usage, and then like obviously like the leaf nodes are the actual usually the biggest problems to tackle. I don't know, for the lack of a better word.
Yeah, it's not. Yeah, the largest leaf nodes. Yeah, I agree with that statement. Is usually what you want to optimize. Typically, with optimization problems, you can solve it in two ways. You can either do the thing faster, or you can do less of it. Those are basically the two vectors that you usually want to be able to optimize on.
Yep. Right. Yeah, I think we pretty much covered the entire blog post. But yeah, if you want
People
to
should still go check it out.
go
Link to
read through it, I think it's also something where I'll definitely go back to over and over again, and like whenever people have questions or like we need to discuss something with someone and then some question comes up, I think it's a really, really good resource to just go back to.
yeah,
Just
the
pull it up.
visuals on that post were outstanding. Made it very easy for someone who's unfamiliar with flame graphs or even profiling to understand how they're constructed and what they mean.
Exactly.
Yes, Frederick, the other optimization factor is we don't do something at all, which I would
Just
argue falls
ignore it.
under the umbrella of doing it less. But yes, sometimes we just need to stop doing a thing in code.
All right, I'm gonna log into Polar Signals Cloud, for which I'm going to hide the screen for a sec.
Okay.
Although I don't think anyone should be able to see anything sensitive there, but just making sure.
Password
Okay.
1, 2, 3.
Yeah, my OAuth password clicking on a button.
I knew it.
Yeah. Those hackers out there, they might hack my single click on a button. You never know. You never know. All right.
Yeah.
So here we are, and today, as the title of the stream says, like we are looking at the Node Exporter. So we run Node Exporter in the observability namespace, and let's take a look.
You want to go through what, as long as we're doing educational on how to profile, you want to go through what all these drop downs and the query you've written here?
Most definitely. Yeah, so I mean, we actually run a bunch of things here in this environment. So we also have Go routine memory and other CPU profiles. However, right now we want to look at the CPU samples that are collected by the Parker agent. And those are right now only CPU samples. But if you need, like, for example, Go specific profiles like memory heap or allocations, those can be scraped. But we'll focus on what the Parker agent kind of returns to us right now. And then these are kind of like the label matchers, similar to what Prometheus does. We run Parker agent on every single node in a cluster or on a machine. Doesn't need to be on Kubernetes specifically. And then while running there, it kind of like tries to gather as much meta information, if you will, about the process that is running, and then attach some label key value pairs to the profiles that are collected. So you can see we have quite a lot of them over here. So like, I don't know, yeah, like Kubernetes version 1.4 of that app. Then like what compiler was the binary compiled with, so 1.19, which kernel is the machine using, etc. So lots of like also low level key value pairs or labels that we can use. But right now we are interested in namespace observability and then the executable or COM called Node Exporter.
Yeah, and the comma separator here basically just makes this a conjunction. So this is observability and com is node export. It's not an or.
Exactly. Yeah. I don't really think you can do an or. At least you might need to kind of like exclude things with like the doesn't match. So we can also say, let's give us back everything except Prometheus, where we say com not Prometheus, for example. Yeah. We can do things like that, but let's look at Node Exporter. And then, yeah, we can say how much look back do we want to do. Right now, maybe let's look at 3 hours. We can also get into like specific absolute timestamps, or we can also just drill into a specific time frame by selecting it on the graph. And now we see a bit more or clearly visualized what was going on here. Seems like the flame graph isn't loading for some reason. Icicle graph, flame graph. All right, let's go back to 3 hours then. Okay. I don't know what that happened there.
Bugs.
But
They still exist.
no way we still have bugs.
There's no way.
But yeah, I guess, yeah, looking back at like the last 3 hours of all the node exporter running on our cluster, we take every single sample into account and we merge everything together in one big gigantic icicle graph. And we actually see not too many values, I'm surprised. Only 300 samples. It's not a whole lot. I guess it doesn't have too much CPU activity on here.
Yeah, it's not that busy.
But I think we can already see, I guess, not surprising, the runtime go exit is at the very top. And then we have one function, which is the node collector, being the second highest function, or the actual highest function that is running. And then we can see that we have an HTTP server doing a bit less work. And
some people may not know this, but you can click on the legend up top. So like if we just wanted to quickly highlight all the node exporter things, we can just click on that box. And then it'll do a fancy little highlight for us so we can see exactly where node exporter exists.
Interesting, it doesn't highlight the HTTP server on this side too much, right? Although that's still work done by Node Exporter, I just realized. But it's really...
Lily says, is this a new feature to highlight? Relatively new, I suppose.
I think
yeah,
like
I don't
1
remember.
or 2 versions ago, it landed in Parker as well.
Yeah, and it was in a feature flag for a little bit, I believe, as well. But yeah, relatively new feature, but I find it super helpful. With this profile, it's fairly straightforward to find everything, but sometimes you get extremely large profiles with a lot of different icicles, and the highlighting becomes super handy to find how often certain packages are called.
Yeah, exactly. But yeah, this is like the HTTP server, and most of this time is really just serving the metrics that Node Exporter collects. So we'll probably, I mean, this would be another...
I was just commenting on it's serving metrics is 10% of the CPU usage, or 20%.
I think this was like one thing that like kubestate metrics like really re-implemented for exactly that reason, because it spends so much time encoding metrics back to Prometheus. So they like a couple of years ago rewrote most of like how they encode the metrics there. But I think this might be another one. Maybe if Kemal wants to do a stream one day, because he's like a client Golang maintainer, which this falls under, like this might also be something where if something is possible to improve, this is like impacting every single exporter of Prometheus metrics, right?
And it's a huge chunk of the time that the exporter is spending in.
Yeah. Hi, Nicholas.
Welcome to the stream. So we were also late. So
but still in time. Yeah. Don't mention we were 15 minutes late.
We'll cut that out of the recording. It's fine.
It's not even part of the recording because it started 15 minutes.
We'll cut it out. Cut that.
But yeah, okay. So we have like collector.execute, and then beneath that we see various collectors. So there is a Btrfs collector, which is super interesting. Are these nodes running Btrfs on GKE?
It kind of seems like it. I didn't know that either.
Connection tracking, CPU collector, file system collector, memory info collector, net class collector, net def collector, net stat collector. So lots of collectors. Thermal collector.
Yeah. Thank
Very
you, Nicholas.
interesting.
I'm wearing my parka shirt for the stream.
Yes. Good one.
Oh dear, we're having a thunderstorm here, and my dog is freaking out. So he's gonna join us on stream for a minute.
Wait. I'll have to enhance. Well, Corgi's in the stream. I mean, that's a priority.
He's very nervous about the thunder we're currently having here in Minnesota.
Good thing he doesn't know he's on a stream. That would make him probably even more nervous.
Yeah, I don't know. I don't think
it's-
anything makes him more nervous than thunderstorms.
Thunder is really, nerve-wracking.
You know,
I get that.
When you're a little dog, thunder seems really big.
Mm-hmm. Also as a little human.
Probably.
Yeah. All right. I hope he'll get through this.
Yeah,
Give us
me too.
updates, okay?
He's just vibrating. He's so nervous. He gets the whole body shakes.
Oh God. Right. Okay. So
Lily asked, we can disable various collectors. That is true. Yep. You can disable or enable whichever collectors. There's a default set that the agent will run, if I recall correctly, and then you can enable additional ones or disable some of them as well.
Yes. So I guess I don't know how
it's been a while since I've used it.
Then which collector is being run. Where's the main file?
What, isn't it just in the README? I'm sure it's documented in the README, where it's just some flags that you pass.
Yes. Okay. Let's look at the README. I'm going straight for the main goal.
Straight for the main goal. When you could just look at the README.
That's one of the memes. Where you
here we go. Enable by default.
It's been a couple of years for looking at Node Exporter, but I think it's via flags. Yep, right there.
Yep.
Okay, people, I'll make sure to look at READMEs first next time. Okay, so I guess this is like very descriptive, exposes Btrfs metrics. So we have that. We definitely saw contract, shows connection tracking statistics. CPU was there all the way on top. And file system, I believe we've seen as well. Net class and mem info were there. So I think
docs are like IKEA assembly manuals, Nicholas said.
Exactly, that's the meme, yep. You don't look at them unless you can't figure out the next step, right? And then you
guys are doing IKEA wrong. I read through the entire thing.
Sure.
I do.
I think this is one of the occasions where you tell a bunch of stuff on stream that's not real. Like you actually look through this? Like you skim through the manual before you start building things?
No, I go step by step through the manual to build it.
Wow. I only do this with Legos, I guess. It's like 200 steps is kind of hard to just do from the top of your head. Manuals are fun.
Yeah, I learned a lesson when I put together my kids' play kitchen because it took me like 3 hours, and by the end I realized I had put a piece on backwards and had to disassemble the entire thing. So I've learned my lesson with manuals.
Fair enough.
Also play kitchens, the worst.
This is what we do on the stream, discuss play kitchens.
Yeah. All right. So we got a bunch of collectors. Let's go back to the profile.
Yep. So I don't know, like, do you want to like disable them, or why did we look at?
I'm not saying it. I just wanted to remind myself which ones we had.
Okay.
Yeah.
I guess to be fair, like if you see that like this one is taking up almost 6% of CPU time, but like there actually isn't Btrfs anywhere used on the machine, like that is definitely worth disabling, I guess, and you get back like easy CPU cycles.
Yeah, It actually might be worth disabling because we're running this on GKE, so we do not control these hosts. So learning Btrfs statistics is probably not that actionable us from a user standpoint, right? Maybe potentially it'd be actionable. We could use it differently, I suppose, but most likely there's nothing, like even if we spotted a thing in Btrfs, there's very unlikely we could do anything to affect it. So it might be worth just getting back 5% of our CPU time.
Let me in another window real quick, but I'm happy to move this over to the stream, see if I can find anything. Btrfs. Okay, so if we look at this, so this is what we'll do. We'll save CPU cycles by disabling things, which is, I guess, fair.
Yep, as Frederick earlier did point out, the do less or do it faster. One of the things in do less could be not do it at all.
Yeah. Let me pull up the Btrfs.
Yeah. Nicholas said it's a good idea. Many companies he's worked with, observability, they just turn on a bunch of collectors, but most of them could be disabled because of managed nodes. Yeah. If you're going to farm out the management of the nodes, you probably don't need all of the node statistics, and you're just wasting CPU cycles by collecting that information.
So, like, are these Btrfs prefix or anything? I'm trying to figure out, like, what metrics does it even?
Oh, I'm not familiar with what metrics.
I guess it should have this as a prefix, right? But yeah, I
think there's a file for these metrics in the README, says Lily. We could also probably just go look at our Prometheus and see if we can find.
Yeah, exactly. That's what I was doing, like on the site here before I pulled it up. But I can't find any Btrfs.
Frederick says this is not uncommon. We had one company that had misconfigured Istio and saved 55% of their CPU by configuring it more to their need. That's impressive. 55% is quite large.
That's like a lot.
Yeah, every sidecar was doing unnecessary work they didn't need.
Jeez.
Yeah, I mean, I think that's probably really common, especially in the cloud space where you don't have to manage your compute quite as closely, and so you probably end up wasting a lot of CPU cycles. And it's historically, it has been easier to just spin up more compute than it has been to profile your entire infrastructure, which is what we're trying to change here at Polar Signals. Make it easier to profile your entire infrastructure and find those misconfigurations or waste CPU cycles instead of just spinning up more compute.
It's a really, really good point, because like so far I mostly looked at this from we need to like change source code in some deep down part of the system that we're building. But yeah, I mean, like just looking at this and disabling export, this is a really, really good point towards using profiling as well. So okay, let me get back.
Yeah, it doesn't always have to be. It can oftentimes be a no-code change. We also just yesterday were looking at our demo environment and found a bunch of profiles for extraneous programs that we didn't need to be running. So that was just a stop running the programs.
Okay, so this is our daemon set running Node Exporter. And file system, mount point, no collector for Wi-Fi, no collector for this one. And then these are, I guess, not really enabled, but more specifically configured, right? So we want to like exclude like K3s or like Docker and stuff.
Yeah.
So how about we just edit this and put the no Btrfs?
Is that how you disable it?
I hope that was like.
I don't remember from the README, but yeah, let's throw on no.
I'm learning a lesson here. Let me
look at the IKEA manual. See what the next step is.
I always was bad at like reading docs and reading.
Well, yeah, you wanted to jump straight to the go.main.
Already in school, I never read like the instruction for the math exercise. I just straight like started calculating. So it's a lifelong lesson, I guess I'm learning. So It says collectors are enabled by default and can be disabled providing a no collector flag.
Butterfs. All right.
So let's put this one in. Yeah, I'm definitely going to edit the
Wouldn't make
daemon
sense
set
to
in
profile node
production.
exporter with the default collectors enabled. Arthur asked, wouldn't make sense to profile node exporter with the default collectors enabled.
Right. I guess define default here, because what I think we are running is just the Prometheus stack. So it's kind of like still a default, if you will, with
Arthur's point is it's the default configuration is probably the most used worldwide.
Yeah, yeah.
That's true. And I think if we were probably trying to just optimize node exporter for the general case, that would probably be the best idea. We are selfishly trying to optimize node exporter for our use case, for our infrastructure. So this is more I wouldn't say real world, since to your point, it is more used worldwide at the default, but this is a real world example of how we're using it and how we can optimize it.
For what it's worth, we could enable those by throwing them out and see if they show up.
Like, well, let's start with selfishly improving our CPU usage.
I'm actually tempted to see if like the Wi-Fi exporter would start showing up the collector. On cloud, but
I don't.
All right, let's do it.
I don't know. I've never used the Wi-Fi exporter.
I guess it might make sense if you run Node Exporter on your MacBook or something, but
yeah.
All right, Btrfs and deploying. Let's do get pods, Node Exporter, or we can kubectl get pods, observability, namespace, and watch. Okay, I guess that says that they've been rolled out.
That was fast.
Yeah.
Nice.
Minimize this. Let's go back here. And then I guess what we can do is go to the last 15 minutes.
You can also do a comparison to just show off that.
Exactly. Well. But it might take just a couple of... Whoa, that's a new one. I haven't seen that one.
What?
Should be, yeah. Should be able to see it now.
Oh, wow, yeah. Jiggling.
Which one?
Okay.
Disabling the sidebar fixes that one. Let's try and select those 5 minutes. And say 55. So this is something I'm working on as well. So you can compare like 5-minute windows to like a 2-minute window or something. But right now we'll have to like roughly put in the time frames we want to compare. So let's do this for now. And hopefully we'll see as time goes by that the Btrfs thing decreases further and further. I guess we could also just say we want to search for this for now. That would be great. Oh, what happened here? Oh. No one said anything. I'm going way into the future here.
Oh yeah, that's not.
Wait, way into the past actually. 301 and 306. All right. That's why the profile down there looked so crazy. And then if we put this in.
There, that looks more sane.
Okay. I guess we'll have to wait. Yeah, we can see like the different colors here. We can see that like the new Node Exporter versions have rolled out, or like pods have rolled out. Not really new version, but we don't yet have enough data. So let's maybe do 7 past and 5 past. And then over here, I didn't click apply, I guess. Actually, let's do it. I'm completely making my life harder than it needs to be, and this one is just whatever.
There you go.
257. Wow. Okay.
Yes. So in the future, this won't be quite as painful, as we'll adjust the profiles that are different durations accordingly so that you can actually get a meaningful diff. But for now, you have to line it up.
So I guess, let's see if this, whoops, this shows up. I guess we might need to do it the other way around, actually. So relative, let's do 5 minutes, whatever, and then let's do this one.
You know, it'd be a cool feature if you could just drag and drop these windows and swap them, and then have it automatically know that you need to diff it the other way.
Yep.
That'd be fun.
Or like, yeah, I guess you'll always have a base and compare site, right? Yeah.
Yeah, and just you can move the window or something. I don't know. Not a UI expert. That's probably a terrible idea.
No, something like that definitely makes sense.
Yeah, instead of having to manually change the timestamps.
The sites do matter here, right? Like,
yeah.
Yeah, now we can see the improvements. Where's the Btrfs collector? Okay, so this one here. Yeah, now we're seeing this. It gotten worse, but we swapped the base and compare sites, so this is actually better now.
Yes.
So it didn't show up in the other one because it wasn't part of the base profile that we compared against. So this is like something we'll also definitely need to kind of improve the UX on. So you need to have the Btrfs collector show up in the base profile for then being able to compare it with the comparison profile. And because it wasn't in the base profile, it just didn't compare it in the overall profile.
Yeah, that probably wouldn't have been an issue had we made the Btrfs collector faster, because then it would have shown up in both. But instead, we just removed it because we didn't need it. So. Yeah.
So this one is definitely a
so
lot
how
better.
Much? It's what, 6% that we
it's
just
like the 6%
with a flag
we seen earlier.
Very cool.
And I guess we could like increase as time goes by. We could increase like the time here, like to like 8 minutes, and then go back here and say 53. So we just have a bit more samples to compare these. Oh no, I said 8 minutes and 7 minutes. Yeah, again, this is something we're tackling now. Okay, this was too much because we see the old stuff here. But yeah, I think you get the point. Like, we definitely have gotten the 6% back. I'll open a new tab so we have this comparison saved for later. But I think we should definitely look if there are more collectors we can disable just like this.
Just go on a disabling features spree.
Exactly.
Let's just delete node collector and think about how much we could save that.
That's my favorite. Like, next to the no code initiative, I think the no infrastructure initiative is my
infrastructure.
So if you want to save 100% of your infrastructure costs, just delete all of it, and you should be good.
Your CTO will love you with this one weird trick.
Yeah. I mean, you might want to communicate up front. But
no, just say you took care of the bill. Let's go.
Exactly. 100%. So where's my bonus?
Something I was interested in. So that 6% that we saved by disabling the Btrfs collector, that was 6% of the CPU usage of the node collector. I'm just personally curious what percentage of that is of our entire infrastructure.
Okay. Of the entire infrastructure or the entire observability namespace? I guess we can.
I mean, I'm curious the overall infrastructure, right?
Okay, let's.
How much CPU did we just reduce? Probably
Right. Okay,
significantly
so
less than
let's
6%.
search for
But
ButterFS, and then we see only the stack trays show up in flame graphs that have that string within them. So now we see, I guess that's due to looking at the last 15 minutes, the overall sample size compared to the overall samples. The ButterFS sample size decreases over time. So this should be going down. Like now it's 2%. Before it was like 6%, right? Kind of a metric, like an error rate going down. So I guess let's look at the last hour before we delete it to just have a bit more data.
If we wanted to look at the entire info there, we'd get rid of
Exactly.
our label matchers.
Exactly. So now we see, okay, this was like 2%. So just of Node Exporter itself. And now, or actually, maybe what an even nicer approach would be to just look at the last hour before we made the change. So let's go and look at 2 p.m. UTC to 3 p.m. UTC. And I think we changed it like too past or something. So this is looking at the namespace observability and how much time did we spend of the entire thing in that Node Exporter ButterFS collector. So you want to explain what we see here?
Yeah, so this is the CPU usage for our observability namespace, which is a bunch of different things. And we're filtering on ButterFS, which for those that didn't catch it, we just disabled in our Prometheus Node Exporter because we're running on GKE nodes, and those metrics aren't that useful for us since we're not managing the nodes ourselves. So what this is telling us is that was 0.1% of our entire observability namespace that we just reclaimed, which is not huge, but
it was easy enough.
It was 6 seconds of work. So,
and then the entire infrastructure.
Yeah, it's way less than 0.1%. Yeah.
Let's see how much of that it is, though.
To be fair, though, we picked a program that didn't have that much usage overall in general. Node Exporter was small to begin with, so.
Wait, that doesn't seem right. It's still 0.1%.
Even better.
Did this update?
Yes, Frederick points out it's huge if it was disabled on every machine on the planet that doesn't have any ButterFS file systems. Yes, absolutely. Yep. If everyone disabled this when they don't need to use it, that's a lot of CPU cycles and energy wasted. And not on the planet. Who knows if Node Collector is running on the International Space Station?
And ButterFS isn't. Very specific.
Exactly. We don't know.
Okay, so
Alfonso asked, why is ButterFS not opt-in?
Yeah, I was just having the same thought. Like, can we, within Node Exporter, somehow do a feature detection of having ButterFS in the first place, right? Yeah.
Yes, I don't know why it was chosen as a default. I don't feel like ButterFS is that popular that it would be a normal default, but I don't know. We'd have to talk to someone who manages the Node Exporter. Nicholas had a great point, though. This actually has a knock-on effect where we'll also reduce the number of resources used in Prometheus, which is true. So yeah, we reduce the CPU usage just from the collector, but that sends fewer metrics to Prometheus, which will then also decrease resource usage in Prometheus as well. So that's a great point, that there are knock-on effects to optimizing things.
Yeah, like definitely if the collector still exposes quite a bunch of metrics, right? Like 100%.
Yeah, so the chat's asking, should we ask or try to open a PR to disable it? But I think Arthur's right that that's probably a very breaking change for a lot of people to just disable it. But
time to cut
definitely worth
version
asking.
2 just to disable ButterFS by default. I think it's still worth like opening an issue and starting the conversation to have this included in the next version in the disabled list by default.
Yeah.
Yeah, it's interesting. There are quite a bunch of exporters that are disabled. Like systemd, for example, I would totally think that there are probably more machines running systemd and like getting value out of this versus Btrfs. But yeah,
I wonder if it's disabled simply because of like footprint, right? Like maybe it's more expensive to profile systemd. I also wonder if like things like Btrfs you could leave them on as the default, and then if they can't find Btrfs, they would shut themselves off. I don't know. Maybe it does do that, and our nodes just happen to have Btrfs. I don't know.
Yeah, Frederick points out that like while we probably won't change it to be disabled by default in Node Exporter itself, like we can still change it to be disabled by default in Kubernetes, and then it will still trickle down into so many clusters and have an impact there. Yeah.
Yeah.
Good point.
Yeah, that's cool. Cool ideas.
So yeah, this was like 0.01% of our infrastructure. So like 100th of CPU time spent in our cluster, though. Yeah, I think
of note, our cluster is not that massive though.
The formatting is off, so it like actually rounds it up to 0.1%, 0.01%, because like down here you can see it's like actually more like this, and we can do the math. 30955. So yeah, I guess like 0.006% of the infrastructure is quite accurate. So I think this is a bit more accurate, just given that we can't show so many suffixes, like decimal precision points here.
Yeah.
I guess the CD is disabled because it's very expensive. Doing it on Kubernetes, the ripple impact is a little bit small. I wouldn't say. Yeah, funny how half the chat, that's what you were laughing at.
Half the chat is Kubernetes maintainers. They can fix it. Go on,
come
chat.
on the stream, and we'll just take over as a Kubernetes stream here.
Here we go.
But yeah,
I don't know if Prometheus ripple effect would be that small.
No, I don't think so. It would be, because like every single OpenShift cluster still uses Prometheus, as far as I'm aware. So like all OpenShift clusters would save like 6% of node exporter time. I don't know if they have if they might have like disabled these by default already, like they can override parts. But yeah, okay.
Yeah,
Lily says OpenShift configures it differently. Yeah. And still, like, I think like the Helm charts for Kubernetes are like one of the most used charts out there in terms of Kubernetes.
Yeah, comparing with the people not using Kubernetes. True.
Yeah. Like disabling it in Kubernetes versus disabling it in Node Exporter. Yes. Yeah.
Yes.
Fair point.
There is probably more running outside of Kubernetes, but that doesn't mean Kubernetes is small either.
Yeah.
Frederick mentioned there are 100K Kubernetes deployments out there probably. So, yeah. I don't know. Easy win.
Easy. And then let's look at the 1 hour and look at Node Exporter again itself. So we gotten rid of the one collector. This bug again. Okay, reload this page.
It's the flickering bug. I've never seen that. Maybe is that Brave browser related?
I don't know. Like sometimes, like very rarely, occasionally, it happens to me that I can't expand into the stacks here.
That's interesting.
But yeah, net class, file system. Okay, this one we got rid of. So file system collector. I guess we can look at the net class collector, but I'm pretty sure these, at least like the net class is exposing metrics. So it would be great for this table to have like the metric prefix show up there already. So I
that'd be nice. Or a link to what the metrics would be, like to a separate doc.
Net
Handy.
class. No, which one did we look at? Short memory is busted.
Was it net stat?
Netstat, yes, I think so. Jeez. It's Friday afternoon, people. I'm sorry. Okay, so something, yeah, netstat subsystem.
Something net stat.
So I can show you how to write the query that says, I want a metric name that says something netstat something. To see, like, I wasn't even.
Will regex match anything that says net stat?
I wasn't even that much up in my random comment. Okay, so we do have a bunch of metrics here.
Now the real question is, are we using any of these metrics, or do we just have? Are we just hoarding metrics at this point?
At least filter by job. Yikes.
Oh, the comment section roasting you about your Prometheus usage.
I have no idea how Prometheus works and what I'm doing, so thank you for helping me write proper queries. But yeah, I got a bit lucky, to be fair, that there aren't other systems exposing netstat metrics here. I could have easily loaded a bunch of way too many metrics into my front end. Fair enough. But yeah, I guess, yeah, the question is, like, do we use any of those? So I think we can look at, for example, the rules here, and then use this like advanced feature called browser search, and not finding anything related to netstat. The other question is then, do we have something in the Kubernetes dashboards?
Yeah.
So let's go into our Kubernetes dashboard folder, or like Grafana dashboards folder. Observability, and this is really just Prometheus that people know, and just a bunch of modifications we do for our infrastructure in the main JSON file. But we do have this dashboard.
I'd like to apologize for the JSON.
Yeah, you can apologize all you want. We'll still use it.
I'm gonna continue to apologize for the reckless use of JSON.
One of the drawbacks for you, though, working with Frederick and I, you'll have to write JSON.
It's like a cancer. It just keeps spreading even when you remove it in certain places.
I wonder who puts it there. It might be, no, it's definitely Frederick, not me. Yeah. Anyway, we have dashboard definitions here from the Kubernetes Mixin and Prometheus projects.
Arthur says he still has nightmares with JSON. That's fair. It is nightmare inducing.
Why?
Why wouldn't you?
You contributed a bunch to the project. Okay. I see, like, just because you contribute doesn't mean you have to enjoy JSON. Okay, fair enough. All right. Sad story. We actually use 2 metrics.
2 metrics?
So netstat TCP retrans segments, I guess, and SYN retransitions. I wonder which.
Do we actually use these? Like, yes, we have them in a dashboard, but are we getting
looked at them? Yeah, that's like, I wouldn't mind disabling them for what it's worth.
I'm suspicious that we actually get value from them. Like, we have them, and I bet they're part of some auto-generated dashboard. But
yeah, they definitely come from. Is there a way to, like, in Vim move up the object levels, kind of? That would be helpful now.
Shift 5 if you want to, like, jump from bracket to bracket.
Yeah, that one, but I need to, like.
you can use Mimir tool to discover if you use a metric in Grafana. I don't know what Mimir tool is. I know Mimir is obviously Grafana's metrics, but I don't know what Mimir tool is. That would have been nice to know before we had to look at JSON it though. Again.
Anything. So anything is doable. So at least like.
Is it like Cortex tool? I assume it has to be, right? Because Mimir is basically Cortex.
Neither of them. So enlighten me, Thor. What is Mimir?
I don't know what they are either. I'm learning from chat.
Jeez.
I don't know.
We're a bunch of.
You know what? I'm going to go out on a limb here and say it's a tool for Cortex.
Where are the binaries?
Or Mimir.
Give me binaries.
Tool. I don't know what it does.
Tool. Cool. The question is, can I go through our OAuth proxy with this? I guess I could.
Okay, but if we're using it to determine if we use it in Grafana, we already know that we use it in Grafana. Yes, so I think it's a little redundant here.
Okay, fair enough. But the question still is like, do we use it somewhere?
Yes. Do we actually look at those graphs? Are they useful for us in anything that we do?
So I'm assuming this would be in the Kubernetes mixin dashboard. Nope. Yeah, how do we netstat network? So in one of these, I'm assuming. Yeah, definitely Kubernetes. Can we find this in the Kubernetes mixin? Anyone knows?
Oh, at Gitpod, we automated relabeling configs, dropping unused metrics using that Mimir tool. Ooh, that would be cool.
Okay, so it's the cluster-wide cluster total network usage.
Okay.
Cluster, so this one. And then I guess it's like one of those.
Yeah, I agree with Nicholas, Arthur. That should be a blog post. I'd be super curious to learn about that. Does it have a feedback loop where it would then tell Node Exporter to just stop collecting that? Because that would be nice too.
All of a sudden, everything's disabled. Again, like that's the FinOps approach that we discussed earlier.
Yes, just turn it all off. Save so much money.
So it has to be these.
It doesn't have access to Gitpod internal things anymore. Okay, well, maybe a kindly worded email to ask them to write it up.
So how do we feel about these metrics?
What am I looking at here?
Them?
Go back. What am I looking at here?
It was these collapsed error within the error section. We use these two metrics to see send segments that were retransmitted or SYN TCP retransmissions.
I have never looked at these graphs before in my life.
Yeah, me neither. And I'm a contributor or even maintainer to Kubernetes mixin. So I'd be fine with just disabling netstat even. I guess we can always disable the disablement. Yeah. So
yes,
enable them again as well.
Revert the revert.
Yes.
Yeah, I mean, I've never looked at these. I'm not even sure necessarily what I would do with that information, even if I was looking at network problems, to be honest.
Right. I guess it's like similar to what we had with like ButterFS, where
we don't control the networking infrastructure. So like if we're having a lot of drop packets or something like that, I feel like that would be an application layer bug if it's something that we can fix. Otherwise, it's going to be I don't know.
Yeah.
I mean, the one caveat with disabling metrics arbitrarily is obviously you don't need it until you do. And if you've disabled it, then suddenly you don't have it when you do need it. However, if it's like a persistent network problem, that might be something that we could then re-enable and observe should we need it. So.
And I'm like, at this point, I'm like fairly certain that like our application alerting is like the thing I actually want to pay attention to. So like if I can like eventually figure out, okay, there's something in the network stack which is why our application isn't fulfilling like the objectives that we do want to run with. That's when I might look at those metrics as like a very last resort. But at this point, it's more to prove that like Google on GCP is doing something wrong, I guess, right? Yeah.
Right. Yeah, and at that point, we're opening up a ticket instead of doing anything anyways. So I think it's probably worth disabling, just because, as we both have agreed, neither of us look at it.
I'm sure someone will look at it tomorrow and be like, where is it gone?
Yeah, we're gonna find out that this is what Frederick looks at every morning with his coffee.
Everyone
checking out my net stat info. And then he's just gonna be mad. This is how we get fired.
Yeah.
Just took away his net stat.
He has a nice coffee machine with graphs he can look at in the morning, so I think this is fine. All right. So this should be rolling out. Yep. Right. This is so freaking quick to roll out a config change. It's nice. Right.
Good job, Exporter. Way to be quick.
Okay, this was like no. This was 37%, like a third of all CPU time was spent in this collector of Node Exporter. Double checking.
Hans asking if we just optimized the wrong thing.
The right collector net class was the one showing up in the profiles.
Yeah, were we disabling net stat and not net class?
Oh my god.
It's Friday, Alfonso. Okay. We can't be held liable.
Disabling random. Oh no.
This is our FinOps. Just disable collectors until someone complains, and then you've saved money.
This is also an entertaining stream, not a stream to be correct.
Yeah, this is YouTube entertainment.
Really, thank you a lot for pointing that out.
Yeah,
yikes.
thank God for that.
Yeah. Okay, we saved. I mean, this also showed up nonetheless. It was like 3%. I guess I was a bit too optimistic here with the 1/3. So yeah. I thought we were dealing with this one, but actually we were dealing with this one. So another like 3%, which is like 9% in total that we saved from Node Exporter by now. Okay, so what about the net class then? Let's get right to that one. But I'm afraid that might be...
We probably use that one.
Is it just net? Oh god,
better be.
Maybe I shouldn't query for net. Thank you to the person that said to put at least a job label matcher in here.
Yeah, I think that was Nicholas.
Yeah, but it's all network, I guess, right? Yeah, so I'm afraid like this one is used all over the dashboards and alerts, etc. So
yeah, we do want networking statistics for a lot of different things. So that one we regrettably probably have to keep.
Yeah, it's like it's everywhere.
Yeah, should we look at the...
Regrettably, we want to know what our network is doing, so...
Should we look at the profile a little closely and just see what it's doing? Maybe we do need a code change? I don't know.
Are we looking at the last hour? Yes, we are. Okay, so diving into this.
Yeah, so why is it using 40% of, I'm rounding up, but 40% of what it's doing?
Should I put the source side by side? Whoa. What is
the side by side?
Sorry?
Oh, you're opening up the source code. Got it.
So we can look at the net class on Linux. 200 lines of code. Okay, so that should be fairly easy to follow. Cool. So first executing all the collectors, and then this is calling the update.
Yeah, it's calling get net class info, which is our big function here.
So
what's
that
that doing?
Must be this one. And then, okay, so what is this? This is like get net class link. So it's just a flag. And this flag, I guess, is it enabled by default? No, it's actually disabled by default. So yeah, I don't think there's anything netlink here that I've been seeing so far. Why is this a bug in my browser? Both windows have the same. Like I'm. Do you see
That's
this
cool.
on top?
It's a cool Brave feature.
It's searching all the tabs simultaneously.
I don't think Firefox does that for me. I want that.
Yeah, broadcasting my search to all the browser tabs. Okay, so I think this is really disabled. So we can focus on this one, which is
Net class by interface, parse net class by interface, and then it's doing a sysread file.
Yeah, this is like implementing the collector interface. Yeah, this one, right? Yeah. So
Tmux features on the browser.
I do have Vimium running, but I doubt that has to do with that.
Could be it. I don't know.
Okay, net class info. Yes, so this is calling net class by interface, and I think this is like again going straight into this function call here.
Mm-hmm.
Now the question is, where is this coming from? And I think this is on the collector NFS struct sysfs. Okay, this is like this is actually from another repo, procfs.
Okay. Let's see what that's.
I wasn't aware this was a different project altogether. So then we go into this one.
And the main branch isn't protected. Tisk.
Wow. Okay, so net class. Yeah.
Hopefully this is it. Internal util.sysread file.
Which one are you looking at? The parse net class? No, which one?
Well, I mean, those functions by themselves aren't terribly interesting because they just call others according to our profile here, right? Yeah. So we want the sysread file.
Yeah. Okay, fair enough. Yeah. I guess I can click through the call.
Based on the profile, it seems like it's opening a file, reading a file, closing a file.
Yeah, so I think this is exactly what we're seeing here now, where we are opening a net class eFace and then the device path, and we're getting all of the files.
All the files in the directory. Util sysread file. That's the big chunker in our profile that we're looking at on the left. Is that sysread file function.
So this is this one. Yeah.
Yeah.
So basically we're opening every single file in the net class directory, sys class net, and then every single interface we are opening and then reading that file. So yeah, this is doing OS open and then reading these buffers or reading into these buffers. Okay, and then trimming whatever length we have read from those files, we trim the buffer to that size.
I think you have the video covering whatever you're highlighting right now.
Oh yes. Nope.
Chat is best.
Thank you for pointing that out. I miss i3. That's why.
I also miss i3.
yeah, buy is cool and all, but like sometimes
it's just a poor man's i3.
Yeah. Okay. So this is what we are looking at. So yeah, this is like the buffer. I guess we could reuse the buffers here. That might be one possibility.
Yeah. Do we see a lot of? We don't see a lot of garbage collection or allocation in this profile, do we?
Not really, not at all.
Reusing file descriptors is a suggestion from Alfonso. That's interesting.
Mm-hmm.
I assume that's what the internal pull thing on the left is. Yeah, this is done in periodic updates. Yes,
Right.
it gets called. However, frequently it scrapes it by default and reads it, converts it to metrics, ships it off. But yeah, that'd be interesting optimization if you could reuse file descriptors to optimize some of this away.
So how would we go about doing that? Alfonso, do you have any pointers on how to accomplish this in Go? Otherwise, I'll go and read through some stuff about this.
Yeah, I've never tried to reuse file descriptors in Go.
I don't even have a hint on how that might be possible.
The first one is preventing reuse. I mean, I wonder, is it just holding the file descriptor after open and then resetting it and reading it? Problem is that you need to have an API and Procfest to read from a file rather than a path. Thanks for tuning in, Nicholas. Appreciate you being here and profiling with us. Take care.
Take care. Yeah, because it's like you're saying it's not like a normal file system we are reading after all, right? But like the procfs is kind of a specific one.
Is it? I mean, isn't it just normal files anyways? Like everything's
It's supposed to be that, yeah.
Some form of, yeah, I don't know enough about Go's usage of the OS package here, but like, can we skip the open every time? Like reset the file descriptor? I don't know how to do that personally. But that would be interesting.
Yeah, I think this.
If we can find a more efficient way to continually read from a file that's constantly updated or rotated.
This one is like opening a file for the first time. So we would do this, and then we get the file descriptor here, right?
Mm-hmm.
And then we use OS new file and pass the pointer to the file description. So OS new file. Returns a new file with the given file descriptor and name. Return value will be nil if the file descriptor is not valid for the file. On Unix systems, if the file descriptor is non-blocking, new file will attempt to return a pollable file with a set deadline method. So we would need to kind of like have oh, it's invalid, we'll open it again and see if we can find something. And then we'll have to like somewhere keep track of the file descriptors for a given path, right? So that we can reuse them.
Right. But I mean, we're probably running out of time here. Won't be able to do something like this on stream, but that's very much an interesting idea. And it seems like it would probably have a pretty large impact based on our profiling.
Mm-hmm. Okay, so this is simplified. Yeah, I'm just reading this comment on top. Yeah.
Yeah, but it does. Yeah, I think the problem is it's doing the open and close each time, right?
Mm-hmm.
when all we really want is that file descriptor, because to do this is call read.
Yeah, so something like this here, on
And
on the right hand side, I think.
Yeah, if we go back to our profile, like how much was open and close percentage wise?
So this open, it's always hard to say. So this was like 12%, just this one always open. And then I guess is it like the defer? Yeah, it must be the defer because like the function one, right?
Mm-hmm.
So this closing is another 10%. So
Okay.
just opening and closing is like 12.5 and roughly 10. So like overall, like 25% of Node Exporter time is spent in these two files, opening and closing.
Yeah, it seems like if it works to just hold the file descriptor and reuse it over and over, that seems like a really easy win, since there's no reason not to, because you're just gonna read it over and over.
Yeah, like this is definitely like underneath using like the OS file descriptors, as you can see here, but I think we can be more explicit about this, right? And then getting rid of a bunch of these open and close calls, or at least have them be lighter. Okay. So I think that's definitely a good thing to follow up on. Whereas the file system one seems pretty small. I guess we can check if we are actually using that one as well, and if we can just disable this. But I'm pretty sure we're using this quite a lot.
Yeah.
So already you can see we have, what is happening?
Yeah, I mean, I believe we use this pretty frequently to determine our disks are filling up.
Yeah. Again, I guess we could drop them upon ingesting label metrics into Prometheus, but then we are more optimizing Prometheus usage or ingestion rather than improving like the node exporter. Then again, we could have like lists of metrics for file system, or like otherwise like all of the collectors really, that to tell it like, oh, we do want to read the file system, but maybe we can save time encoding these metrics because we aren't even interested in, I don't know, some subsystem of or like some subset of the file system metrics, right?
Yeah, potentially. That does seem to be a really small percentage, though. It'd be I'd love to, if we had time, to try that file descriptor reuse, but I think we're bumping up on the end of our stream here.
Okay, so this seems really tempting. Maybe we'll do it offline and see if we can get this to work. Also, I'm like on the Mac right now, but I do have a Linux machine, and you do as well, though, right? Like where we could just run this on the machine itself, not using VMs or anything, and then see if that has an actual impact. I guess you could just run Parker locally and run the binary directly.
Yeah, if we
eventually.
I think if we get around to it, maybe we could start the stream next week with our findings around trying to reuse the file descriptor.
Yeah, that definitely
could be a good way to pick back
up. But let's actually go back to the comparison we had, and let's look at like the last hour and compare like so which times are we looking at? So right now it is UTC, it is 15:51, so 3:51, and we started this roughly at 3. So let's do 3:10. No, 3:10 right here, and then 3:50, so 40 minutes on this side, and then 40 minutes on this side. And let's just do this by selecting the times here. Okay, so now we can see with the colors really nicely, actually. You can see the difference in when we deployed. So this is also kind of cool to see, okay, we can compare those 40 minutes.
What is that huge spike?
Good question. I just the latest one.
Yeah, I'm just curious. I mean, it's
yeah, we can check that out.
relatively huge. It's overall not that big, but just curious what it's doing in that.
Okay, let's see if this comparison works. No. Please compare. Yikes. Reading base profile accepted column. Can I get around this somehow? Let's try 20. Nope. Why is this not happy?
I don't know. It's an annoying surprise feature we have.
Okay, something's not working here. So sadly, this isn't using persistence just yet. So all of this is in memory. I wonder if we like switch over to this one, we might be able to run it.
Yeah, careful. Okay.
Right, but you wanted to see what that spike was.
Yeah, I was curious. Just
I have the feeling I just oomed something.
you might have.
Is it?
That's probably a good place to end. And we broke
Yeah,
everything, and we're going
broke
home.
all of it, but we also saved 6. Why is it like opening the window on this screen?
We saved even more CPU by killing it.
The FinOps approach. Okay, I'm just
CFOs love it.
checking if yeah. I can see. No, everything should be running smoothly. I don't see restarts in the last 5 minutes. CPU samples. Okay, so at least we get that one. Let's check out the spike. So let's use this one and this one. Something about the comparing modes isn't working quite well, as it seems.
Okay.
There we go. Now it worked. So it looks like interesting. It looks like everything kind of like spiked, right?
Interesting. I wonder. Yeah, I don't know. I wonder if it's just the sample got it at a time where it was most heavily used, or I don't know.
Was it like a restart, but it had like the same label set, which is why like Parker just sees it as the same. Oh, thunderstorms.
The worst.
So 22 minutes ago. Is this like 22 minutes? No, this is like 10 minutes ago. Yeah, no idea what happened there in Node Exporter. But
okay, I was just curious if there was anything new that we hadn't seen before in the profile, but it looks like it's a lot of the same stuff.
Yeah, I guess this should be just overall like polling and retrying with an interval, right? So I can't really explain what happened there.
Yeah. Okay.
Let's try this one last time. Maybe this coming back as well. Nope. Just randomly select time frames here. Nope. Okay.
All right.
But I guess
about it
we
for Friday.
roughly saved 6% by just disabling the Btrfs collector.
You know what? And we found another 20% optimize out if we reuse file descriptors.
Yes, that would
So.
be. It would be pretty great to do that. I think that might be an interesting. I don't know if we just do another stream at some point where we just dive into that. I think that might be also quite the interesting thing to do on the stream, to just see file descriptors, etc., how they work, and then see how the performance could be impacted there. But yeah, then probably like running from a Linux machine just to make our lives easier.
Yeah.
I guess we didn't really contribute or write any code, but I think the follow-up is to definitely go to the Kubernetes project and disable the Btrfs collector. Has anyone actually gone ahead and...
Thanks for tuning in, Samira. Appreciate being here. Yeah. Well, we didn't contribute any code changes, but I think we did highlight some great ways to optimize your infrastructure without using code, right? Just disabling things you're not using, adjusting configurations, I think are pretty easy wins for people.
Let's just quickly write this. Disable the Btrfs.
Where are you writing?
I don't share my screen anymore. That is right. Disable the Btrfs collector for Node Exporter by default. We have seen in profiles that Node Exporter is spending 6% of its CPU time in the Butter.
You want to grab a profile and upload it so we can share a link as well?
That is exactly one idea I have. Let's see. Probably won't show up in this last hour anymore, right?
Oh, did it rotate out the memory?
So let's see if we can do 2 to 3 p.m. Something
unhappy.
Doesn't like it.
Oh, you know what it is?
No.
I think we did rotate out that underlying memory.
Yeah.
Because the graph is rendered from a different table.
Right, let me hide the screen real quick and go to our persistent project.
Secret memory.
And there's something as well. Well,
okay.
Maybe we'll find another profile again where we see that this is using 6%.
We'll just have to link them to the stream so they'll believe us.
So we have seen in profiles that Node Exporter is spending 6% of CPU time in the Btrfs collector, disabling the Btrfs collector.
Yeah, share a screenshot from the stream.
Yeah,
that's a suggestion.
Cool.
I think we share a link, right? Our referral link. Monetize this stream.
Monetize like the people of me profiles, right?
Yeah.
Disabling the Btrfs collector for most classes is probably a good idea.
I have to watch an ad before they can get the profile. Yes. Pre-roll ads for profiles on pprof.me. You need to make Alfonso our head of monetization.
Right. So if somebody wants to write some JSON, here's your chance.
Nope.
Don't say no like that. We want to encourage people, Thor.
Someone wants to write it in something other than JSON. I encourage
Rewrite
you.
the whole project.
I encourage you to replace all the JSON.
You're such a troll. Right. I guess we'll at least have this here, and then we can find a screenshot from the stream and put that into the issue later on.
Yep.
Cool.
Cool,
All
cool,
right.
cool.
Anything else?
No, just thanks to everyone who tuned in, and thanks to anyone watching this recording later. Appreciate you being here.
I guess today's lesson was that you don't always have to write code for you
Yes.
to have impact using profiling. You can just like look at the profile and see, well, btref collector isn't of any use for us. We should definitely disable this. And yeah,
I think that's actually a really huge thing to point out, because profiling might be done by companies' infrastructure teams, which maybe don't control application code, and so they may often throw profiles over the fence to teams that do control application code, but they may control a lot of the configurations of other things running on the systems that they can adjust. So
yeah, I think that's a really good lesson there. All right. Yeah, again, I can I guess put the blog post that Kemal has written, the awesome one on ice and fire, flame graphs, icicle graphs, into chat. So if you want to check that out, again, go ahead. We definitely have some more blog posts in the pipelines. I think we have enough stream ideas for Let's Profile in the pipeline as well, so we can stream the next couple of weeks. And I guess like the week in 2 weeks, we are actually, most of us, at our company offsite in Berlin. So I don't know about that week, but I think next week might be.
it'll be a really fun stream then.
I think it might be fun to just stream in person. I don't know if that would be possible, like from the same room, like actually connect 2 keyboards to a computer and do some pairing or whatever.
We'll do the NCIS version where we each type on half of a keyboard.
That's why people have split keyboards.
That's right. You get this half, I get this half.
I want the vertical split, the horizontal split though, where one person has the space bar and the other one has the escape key.
All right.
Yeah, we'll see. We have ideas. We'll be back. So check out Twitter and the YouTube channel, etc., to not miss out on those. But we have more ideas for streams and blog posts, obviously, as well. All right, Thor. It was great hanging out.
Yeah.
I loved your shirt.
Thanks for joining me.
And I hope your dog made it through the thunderstorm.
Yeah, he's doing okay. It stopped thundering outside, so.
Okay, good. So we can leave the stream on a happy note. At least the thunderstorm stopped. Great. All right. Yeah, I think that's it. Take care, everybody. Have a wonderful weekend. Bye bye.
See you later.